good bugs and bad bugs. I suppose with the ever-increasing number of people, we can count on there always being more good bugs and bad bugs. How to attack the bad bugs? Well, that's one of the questions we have today for Dr. Peter French. It involves things called phages and CRISPR. And yes, I'm hoping that Peter will help us to understand what these are and what the biopharma industry is doing in response to these in the war against bad bugs. What can you tell us about this, Peter?
Well, Fiona, it's a very interesting coincidence that one of the most exciting applications in gene therapy has a lot to thank the war on bad bugs for. A technology that's been used to try to affect and kill bad bugs, the bugs that have become resistant to antibiotics, relies on an old technology that's resurfaced. The problem, first of all, is that antibiotic resistance has become a significant issue worldwide. Whilst it's mainly arisen in healthcare and aged care environments, it's now becoming more common in the community. And these bacteria, when they can infect people, can cause a range of serious and life-threatening diseases. Things like pneumonia, bloodstream infections, sepsis, and in surgery can infect wounds. And ultimately, the infection with these antibiotic-resistant bugs, things like MRSA or MRSA, multi-drug resistant Staph aureus, really present a problem because the health community currently has no weapons left to fight it. Even the antibiotics of last choice are not available because they're resistant to that as well. So this is a growing problem as the increased use of antibiotics has led to this issue.
What are a few of the companies that are working on things to kill superbugs? Is superbugs the right way of describing them?
Yeah, these are superbugs. I mean, the Centers for Disease Control estimated that around 23,000 people die in the US each year from superbug infections. The companies that are working in this area are using a variety of technologies, but the one I'd like to talk about today is a technology called bacteriophage. But they're companies like Amplify Biosciences, which was originally an Australian company. C3J Therapeutics is an American company, and C3J have acquired Amplify, or a subsidiary of Amplify at least. It appears as though C3J Therapeutics and Amplify realised that they are the leading companies in this space because they announced on May the 9th that they had merged to form a new company, Armata Pharmaceuticals Inc. This appears to me to be a very clever move, as the company now has a diversified platform that utilises the IP from both companies and a range of expertise in both research and manufacturing, and a range of patents that should make the company the leader in phage-based approaches to multi-drug resistant bacteria. Armata Pharmaceuticals is definitely one to watch in this space. Intralytics in the US, Adaptive Phage Therapeutics also in the US, BioPharma, which has been acquired by Chinese-based Phage Lux, Gangagen Biotechnologies in India, New Horizons Diagnostics Corporation in the US, and Phage Biotech Limited in Israel. There's a number of research groups as well that are working in this area. A very big Centre for Innovative Phage Applications and Therapeutics has been launched at the University of California, San Diego. And
have they been working in it for a long time, or is it all fairly recent?
Well, phage therapy was discovered 100 years ago, but in the 1940s, when the West discovered antibiotics such as penicillin, it disappeared behind the Iron Curtain. And it's really only has resurfaced probably in the 80s and 90s as the problem of multi-drug resistant bacteria has come to the fore. And now these companies are really, probably over the last 5 years, have really decided to dedicate some serious effort to this.